For 5-HT1A receptors, it depends on if it's the pre or postsynaptic we're talking about. Because of course, there are pre and postsynaptic receptors. And of course, located in different parts of the brain. So like, that's psychopharmacology for you. Yeah. Just really... Anyway, yeah. But one thing I want to emphasize is this is also partial agonism. So think of it like an electric fan, which I cannot lift into. Okay, it's visible. Think of it like an electric fan, just barely visible. I need a green screen. You know, the 1, 2, 3 buttons at the back when we ask like, hey, what's your favorite button setting? 1, 2, or 3, right? Or 0 if it's summer and you're masochistic, I guess. Anyway, for partial agonists, so we think of it like if the full agonist were like a number 3, a partial agonist would be like a 1 or 2, right? And an antagonist would be 0. If you're coming from an agonist, okay, it fell. Coming from an agonist, everything is falling apart. I hope you're not, though, you watching this video. If you're coming from like and full agonist, which is like a 3, so it's like very strong wind, blowing and all. Bringing it down to partial agonist activity, bringing it down to 2 or 1, the wind would feel weaker. That's what we mean when we say it's kind of like relative to a full agonist, a partial agonist feels like an antagonist. So the intrinsic activity just kind of like goes down. So think of it like an electric fan. Okay, so when you say partial agonist, yes, it is an agonist, but compared to a 3 in an electric fan, this will just be like a 1 or 2. So it kind of feels like less. Feels like an antagonist. So let's start with the presynaptic receptors because that's less complicated to deal with. When you say presynaptic, autoreceptors, so like their brakes, Breno. Normally, when serotonin binds to the presynaptic receptors, it will lead to... So at the number 3 setting, that's a full brakes. Full brakes, no serotonin release. Okay. If there is no serotonin, then there is no foot on the brakes. And serotonin is just gonna release. Swoosh, go serotonin. Now, if I kind of put my foot on the brakes, slightly, but not fully, just slightly, relative to no foot on the brakes, putting my foot on the brake even just slightly can kind of bring down the serotonin release. Not fully, but just a bit. Enough that postsynaptic 5-HT2A receptors will have less serotonin. Because again, my foot is partly on the brakes. So there will be kind of less serotonin. Not as much as if it were like a full agonist, but still, enough that, okay, there'll be less serotonin. And then less serotonin to bind to 5-HT2A receptors. They're not activated, so it's as if you gave them an antagonist. Because an antagonist, the 0 setting, it's as if, well, there's nothing binding to it. So no serotonin binding to 5-HT2A receptors, blah 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 from earlier. So no glutamate, no GABA, more dopamine, disinhibited release in the nigrostriatal pathway to displace the excessive D2 antagonism there. So that's presynaptic. What about postsynaptic? The postsynaptic at a different part of the brain, this is at a different part, the prefrontal cortex. How does this lead to, similar to pre, so different part of the brain, but same result, more dopamine in the striatum. How does that happen? So the long stick of it, there's a lot going on here, but it's actually a bit similar in principle to 5-HT2A receptor antagonism. It's like a chain reaction of sorts. So here, partial activation of the 5-HT1A receptors here. Okay, the prefrontal cortex will lead to inactivation. So inactivation of glutamatergic pyramidal neurons. So you kind of see where this is going. Less glutamate release. So less glutamate release means less GABA release. And less GABA release, disinhibited dopamine release into the striatum. So again, similar in principle there. Now, Besides, of course, less EPS and, as I mentioned, less prolactin elevations, you won't expect as much secondary negative symptoms with the 2nd-gen, 3rd-gen antipsychotics. Why is that? The 5-HT2A receptors antagonism, they also contributes because the downstream dopamine release can also happen in the mesolimbic pathway, particularly in the nucleus accumbens. There you go, the nucleus accumbens. So again, we only need 60% T2 blockade. So if you can bring that at 80 to 60, even in the nucleus accumbens, that will lead to less secondary negative symptoms. Take note, this is not primary negative symptoms. All of these receptors here, they can only improve secondary negative symptoms. Okay, so on top of the downstream dopamine release from the 5-HT2A receptor antagonism, 5-HT1A partial agonism. So besides the dopamine release, 5-HT1A partial agonism is also something that's involved in brain-derived neurotrophic factor expression. This will be explained more in depth with the antidepressant pharmacology playlists. Again, links below. But in short, this is a protein that is involved in increasing connections, improving connections between brain cells, between neurons. So helpful for learning healthier patterns of thinking there. 5-HT2C receptors, blocking those can also improve neurotransmitter release. 5-HT3 receptors, apparently they're not just involved in the chemoreceptor trigger zone, they also have roles in neurotransmitter release. So the full set of serotonin receptor subtypes that are clinically relevant along with their functions, they're more detailed in the so-called antidepressants playlist. This is just the ones relevant to our discussion. 7. So 5-HT7 receptor antagonism can also factor into serotonin release via GABA. And then you have the alpha-2 receptors. Alpha-2 receptor antagonism particularly. Normally when we discuss clonidine and ANS, it's very, very simplistic. You have just alpha-2. Okay, you activate alpha-2. This and that happens in the CNS and outside. But here's the thing. Alpha-2 receptors, not only do you have to think about alpha-2 receptors in the brain and outside the brain, so that's 2, right? But alpha-2 receptors have 3 subtypes minimum. Both in the ANS and in the CNS. Meaning 3 times 2, you have 6 different alpha-2s to think about. And this is just like one of them. Okay, so when you see alpha-2, it's not in Stahl's. I'll have to link something here. Anyway, you can just comment and I will try to provide you resources on alpha-2. Basically, there are like 6 depending on whether they're CNS or ANS, and if it's like alpha-2A, 2B, or 2C. Right? But this is just like one of their functions. Okay, that's for the mood effects, for less secondary negative symptoms, and this is also why particularly 2nd and 3rd generation antipsychotics, you see them used a lot in bipolar disorder, and some even as add-ons, as adjuncts in unipolar depression, and perhaps some in anxiety disorders as adjuncts as well. These are the possible reasons. Now, another mechanism, and this is unique to 3rd generation. The 3rd generation, that's a more, you don't see this in all the references, but usually when we say 3rd generation, we refer to the PIPs. And well, okay, fine, one RIP, but in the Philippines, we only have the PIPs anyway, so that's cool. Particularly aripiprazole and brexpiprazole. I ignore brexpiprazole because it's like super financially toxic, like not worth the price tag. Like with oral paliperidone, those 2 are just not worth the price tag. One mechanism unique to these 2 is they are partial D2 agonists. So they're a bit closer to the antagonist side. So think of it like if it were an electric fan from 0 to 3, if antagonists are a 0, these would be a bit more like, they wouldn't be 2, they'd be like 1 or 0.5. So a bit closer. So when they bind to D2 receptors, they're not like fully shutting off the electric fan. There's like a little wind, but like just very, very little. So in that sense, even if there are a lot of D2 receptors blocked, there's still some wind allowed through in the nigrostriatal pathway, such that, and even in the infundibulary pathway, that you would see less EPS, less hyperprolactinemia. In fact, there are even some reports where aripiprazole can decrease prolactin because again, it's a partial agonist. So it can like slightly activate the D2 receptors in the anterior pituitary. I guess it's their one hypothesis is the D2 receptors there are a bit more sensitive, such that just a little wind, little electric fan activation there, it's like whoosh. So okay, no prolactin for you. So something like that, I guess. Alright, so that's just an overview. If you want to go into more details, Stahl's like has like just lots more diagrams and lots more to say about this.